In this lecture, we are going to talk about modifiers. Modifiers in Java can be divided into two categories: accessibility modifiers and special modifiers. Now, you might be familiar with accessibility modifiers. There are three keywords in Java: public, protected, and private, and there are four categories of accessibility. Now, the fourth one is if you do not use an accessibility modifier. Okay? Now, modifiers, what are they called modifiers? These are Java keywords which, if you place them in front of a variable, or you place these keywords in front of a method or a class, they modify the behavior or the property of the class, the method, or the variable. That's why they are called modifiers. They modify. So accessibility modifiers modify the accessibility of the method or the variable. Okay. Now, what about the other modifiers? We have three keywords here. Some books will call them special modifiers. Some books will call them non-access modifiers. Doesn't matter. Basically, these three keywords, final, static, and abstract, if you put them in front of a class or a variable or a method, they will change the behavior and property of the class, variable, or method as well. Let's take a look at them in turn. Let's start with final. Okay, now the final keyword can be applied to a class, a method, or a variable. When applied to a class, like this, public, final, class, class name, open curly brace, and so on. Okay, what is a final class? A final class is a class that cannot be extended from. In other words, you can't extend a final class. Now, if I'm not wrong, let's take a look at string. If I'm not wrong, string should be a final class. Okay, this is the string class. Look at the way it is declared. It is a final class, which means that if you try to write a class which extends string, for example, public class, my class extends string, you'll get a compilation error. Alright, you can't extend a final class. What about a final method? If you declare a method as final, basically public, final, the return type, the method name, and so on. Now, a final method is a method that cannot be overridden in a child class. Okay, if the method is not marked as final, it can be overridden in the child class. If it's marked as final, you can't override it. You get a compilation error if you try to. A final variable is a constant. Okay, you can give it an initial value, and you can't change it later. Now, by convention, a final variable will be in uppercase, all uppercase. If you look at for example, the integer class. The integer class has got all these are finals. You see, public static final. I'll cover static very soon. Public static final int max value. Uppercase to denote that it is a final attribute. That means you can't change the value. So you can use it directly. No, you can retrieve the value of max value, but you can't change the value. That's a final attribute. Now, what about abstract? Abstract can only be applied to a class, okay, and a method. There's no such thing as abstract variable. So when applied to a class, now this is a bit of a revision if you have already covered the inheritance series of lectures, right? An abstract class is a class that can't be instantiated. You cannot create an instance of an abstract class. An abstract class may contain abstract and or concrete methods. Okay? Compare that to a concrete class which cannot contain abstract methods. An abstract method is a method that has no body. You only have the method signature and a semicolon. And an abstract method is to be overridden in a child class. Okay? Now the last special modifier is static. Now, you can have a static method, you can have a static variable. Um, you you may have a static inner class, but I'm not going to go into inner classes and what is a static inner class. Okay, so for the purpose of this lecture, just just let's keep our discussion to a static method and a static variable. Now, a static method is one that belongs to the class. A static variable is one that belongs to the class as well. So sometimes static methods are known as class methods. Static variables are known as class variables for that reason. What do I mean by a method or variable that belongs to the class and not an instance of the class? Now, this is a class called demo. If you write a attribute like that, private int private int uh, instance counter, for lack of a better name, public int get instance counter, and basically return instance counter's value. Okay, this method is a very normal method. You have seen this so many times. Is what we call an instance method. It belongs to an instance of demo. Okay, it belongs to an instance of demo. To use it in main method, I create a new instance of demo and I call d.get instance counter. In other words, when you call the instance method get instance counter, you must say call this instance method of this particular instance, this one, the instance, the address of which is stored in D. Without an instance of demo, you can't call its instance method. Okay, because it belongs to a particular instance of demo. And if you have 100 instances of demo, each of them will have its own instance method. And each may return a different value. Correct? Now, when I say a class method or a static method, what do I mean? I'm going to declare a static variable called static counter. All right. Okay, let's declare this variable as a private static variable first. Okay, I'm going to provide a public static int get static counter method. Okay, this is a class method. Okay, also known as a class variable. Might as well provide the get the settles as well. All right. So void set equals to I. Let's say I is the. Let's do a fast one. Okay, this is the setter. Returns nothing. Set static counter takes in I and it sets the value to I. Okay, what have we got here? A class called demo. This is an instance variable or instance attribute. Okay, the getter and setter both are instance methods. They belong to an instance of demo. This is a static variable. Okay, to make it static, just insert the static keyword in front, the modifier. These two are static methods. All right, same thing. Just put a static keyword there and it becomes a static method. And they are the getter and setters for the static variable called static counter. Let's save everything. Now in test, let me deal with the instance method first. The instance variable. I can do something like set instance counter. I'm going to pass in 100. Okay, this is demo d1. I'm going to create a new instance of demo called d2. I'm calling d2.set instance counter. Let's set it to 99. Okay, d1.get instance counter, and I try to print out. Okay, realize that D1's get instance counter and D2's get instance counter will return different values, which is which is expected, right? So D1's get instance counter return 100 because the value of instance counter in the D1 instance is 100, and for D2 it is 99. Now each instance of demo can have its own value for the instance counter. But what about the static attributes? Okay, how do you assess a static attribute? How do you assess a static method? You do it class name dot method name. Like that. There's no need for you to create an instance of demo. Okay, just the class name, a dot, followed by the static method name. And how do I retrieve it? Same thing. Class name dot method name. In this case, let me save it. That's it. It prints out 88. Now, when I say this method belongs to a class, it means that there's no need for you to create an instance of demo to use it. You just use the method directly. Class name dot method name. It is independent of any instances of demo. You do not need to create an instance of demo to call this method because it does not belong to an instance in the first place. Okay, you have seen some static methods. For example, in the integer class, this integer class, right? We have integer.parseIn. Now this is a static method, which means that you can call it directly class name dot static method name integer.parseIn. Okay, when you use integer.parseIn, you can just do this, right? There's no need for you to create an instance of integer. Okay, and I.parseIn. There's no need for you to do this. The reason is because parseIn is a static method. So having said that, what about static attributes? Now, static attributes belong to the class. For this demonstration, let's make static counter public. Okay, let's make static counter public. And let me access static counter. How do I do it? I access it directly like that. Class name dot variable name. Let me set it to, let's say, 25. Okay. Save it. What I'm trying to demonstrate to you now is you can access a static attribute directly using class name dot static variable name. Oops, what's the error here? We have a problem with private, okay, because I forgot to change. Oh, I changed it to public, but I haven't saved the file. Save everything. Let's try again. Cannot find symbol. Oh. Line 5 of test. Cannot find symbol. Do you know why? No brackets here, okay? No brackets here. I'm not calling a method. I'm actually calling using a static attribute directly. See? I changed the value of the static counter to 25, and when I try to retrieve it, it prints out 25. So no matter how many instances of demo you have created, it does not matter. There's only one value stored in this class level variable called static counter. It does not matter. In fact, you do not need to even create an instance of demo. Okay? So when we were looking at integers fields, we saw one, right? Max value. Okay, we are saying that it is a final variable, meaning it's a constant. You can't change the value. It is also a static variable, which means you can access it directly using class name, which is integer.maxValue. Class name dot variable name, integer.max value, and it is public. So when something is declared, variable is declared as public, static, and final, basically it is a public constant. Anyone can use it directly. Okay, if you want, you can just use integer dot max value directly. You can't change its value, you can only retrieve it because it is a final attribute. Okay, and you try to run test and you see that 214 is the maximum possible value you can put into an int. Okay, a variable of int type. If you try to put in a number which is bigger than 21474, you're going to have an overflow issue, and the number represented will not be accurate anymore. Okay, so this is a useful, public static constant. Now there's one rule which I want to talk about before we end this session, is that a static method such as getStaticCounter cannot access an instance variable. Now in this example, the static method is accessing a static variable, which is not a problem, okay? Because this belongs to a class and this belongs to a class. And both of them do not require the existence of an instance of demo, okay, to work. On the other hand, let's change this code a bit. Instance counter. Okay, let me get rid of the rest so that we can focus on look at this code here. We have an instance variable called instance counter and a static method called getStaticCounter. Or let me change the name to getCounter so that it doesn't sound so weird. And it's trying to return the value in instance counter. Do you think this will work? Let me save this. Okay, and try to compile demo. Look at compilation error. You will see this quite often, and you will have to understand what causes this. It says on line 5, which is the highlighted line, non-static variable, which is instance counter, cannot be referenced from a static context. Now this is a static context, from this open curly brace to the closing curly brace of the static method. What they're trying to say is that within a static method, you cannot access instance variable instance counter directly. Now the reason is very obvious. When you call getCounter, which is a static method, you may not already have an instance of demo. So we have instant attributes and methods living in a different plane altogether as static methods and attributes. Okay, they are in different planes. It's like ghosts can't see man and man can't see ghosts. Okay, they exist, but they are in different planes. It does not make sense here for a static method to return the value or make use of the value of an instance variable, because in the first place there may not be an instance of demo at all. Okay, so if you see this compilation error, that's the reason. A static method cannot make use of an instance variable directly. Now, what is the most famous static method you have seen so far? Main. Alright, main is a static method. And why is main static? Because when main is called, who calls main? The Java virtual machine. When main is called, no instance of test is created yet in this case, because main exists in test. When main is called, the virtual machine does not create an instance of test. So it calls main directly. Okay? So there is a reason why main is static. And of course, a static method can call another static method. No problem. Do something. Okay, system.out. It does something. Blah blah. Look at these two methods. Okay, both are static, and main can call do something directly. Like this. When I compile test and run it, has any instance of anything being created? No. No instance of test has been created. Okay, but main is invoked, and main invokes do something. No instance of test is created. So a static method can call another static method directly. Now, if do something is changed to an instance method, you get a compilation error which is very similar to what you saw just now. Non-static method do something cannot be referenced from a static context. This is a static context. You cannot call do something because do something belongs to an instance of test, and there's no instance of test yet. Okay, related error. This error is related to what we just discussed about 2 minutes ago. Now, how can we call do something in this case? I need to create instance of test and then do something using t. This will work. Basically, what I'm trying to say is that when the JVM or the virtual machine starts the program we're calling main will create instance of test. I'm calling it a do something method belonging to this particular instance of test. Save it. This time when I compile, it will compile. And when I run it, it will run. No problem. Okay? So I hope this demonstration has uh, made you clearer about what static attributes and static methods are. Okay, that's the end of this session.